Hey, this is Get Ready for Calculus, Skill 6, Identifying Domain Restrictions. We've looked at the Remember How problem. Now let's go through the rest. So on domain restrictions, we're looking for a few things. We're looking for square roots of x because we cannot have square roots of negative numbers. Those are imaginary. We're going to stay in the real world in calculus. We also can't divide by 0, so we're going to look for those as well. We're also going to think about domain restrictions with some of our trigonometry, with some of our trig graphs and so on, trig functions. So here we go. The domain of this. Well, this radical, this square root, cannot be 0, right? In fact, it cannot be less than 0 is what I should say. It can't be negative. So we don't want it to be less than 0. So let's figure out where that happens. So I'm going to solve this. I'm going to add that 5 to the other side, divide by that 2. And I'm going to find out that x cannot be less than 5/2. So my domain then would be x can be anything greater than or equal to 5/2. It can be 5/2. That gives us a square root of 0, which is 0, and that's allowed. Okay, so now we have the domain of this interesting piecewise function. We need to look at each piece one by one. We'll start with the yellow piece. Well, there are no domain restrictions for x squared. So for that one, the domain is all real numbers. Now, that's okay. We need to look at what part of this function's domain belongs to x squared. That's everything less than negative or less than or equal to negative 2. So there are no domain restrictions so far. So far the x less than or equal to negative 2 is okay for the first piece. So now let's look at that second piece. Well, we know that second piece, the domain cannot be 0, right? We cannot divide by 0. And what I see is that 0, the problem there, that is in the domain of this second piece, which is x greater than negative 2. So that means that 0 is a problem for this f of x, this function. So my domain is going to be everything from negative infinity up to 0, and then picking up at 0 again and going to positive infinity. All right, what about this next piece? Again, a quadratic doesn't matter. Anything can go in for that. We don't need to worry about that. I see a potential issue here. So let's go ahead and work on this. Well, okay, we do not want that denominator to be 0. So let's figure out what makes that 0. Subtract the 3. Negative 3 makes that 0. Well, here's the interesting thing about the second piece of this function. Negative 3 belongs up here in the first piece. So negative 3 does not belong in the second piece. If we have an input of negative 3, we will not be using the second piece at all. So the only place that second piece, 1 over x plus 3, gives us a problem is at negative 3, which can't go into it anyway because it's not part of the domain for this function in that piece. Therefore, the domain is all real numbers. We can use everything because the only problem doesn't exist in the correct piece. Okay, that's a little weird. All right, the domain of arc sine of x. Now, we're not asking for the domain of sine. The domain of sine would be all real numbers because we can go left and right to infinity. Arc sine or inverse sine is the domain of basically the outputs of sine. And so we know that a sine graph goes from negative 1 to 1. And that would be the domain of the inverse. Now what about the domain of the inverse or arc cosine of x minus 2? Well, the graph cosine of x minus 2, cosine starts here at 1 and goes like that. Well, x minus 2 being the inverse would be shifting that down to negative 1 and going like that. So the domain of the inverse is going to be from negative 1 and negative 3 down there. So we'll say the domain starts at negative 3 and goes up to negative 1. Whoops, I should use brackets there because we can actually include negative 3 and negative 1. All right, next one. This is a fun one because we have two problems. We have the denominator can't be 0, and we have a square root can't be negative. So let's just find when both of those are a problem. When does that x minus 4 become negative or less than 0? We don't want that to happen. So we can't have anything less than 4. Well, we also need to figure out, well, when does that denominator make 0? We don't want that to happen. So we actually find out that x cannot equal 4. So this first restriction says that the domain can be anything greater than equal to 4. This domain says it can be anything except for 4. So whenever we put those together, we realize we can't be greater than equal to 4 for the whole problem because we're not allowed to equal 4. So our domain is going to have to start at 4, not including 4, and go up to infinity. Two more of these. All right, again, we have two issues. We have a square root and we have a denominator. However, the square root and the square cancel each other out. And all that you really need to think about that is any negatives we put in for x will turn into a positive by squaring it. So we'll never have the square root of a negative number. So that's never the issue. It's just when does that denominator make 0? And of course, 0 is the input for x. That gives us a problem of dividing by 0. So our domain goes from negative infinity to 0, picks back up at 0 up to positive infinity. And last but not least, domain of this, we have a quadratic expression on the denominator. To find out when it becomes 0, we want to factor it, x plus 3 and x plus 2. And then we're going to set each of those factors equal to 0, or we'll say they can't equal 0. So x cannot equal negative 3, and x cannot equal negative 2. So in this case, everything works for the domain except for negative 3 and negative 2. If we're going to write it out with interval notation, we'll say we start at negative infinity up to negative 3. Parentheses, we pick it up at negative 3 and go only up to negative 2. Then we pick it back up at negative 2 and go to positive infinity. All right, so that's a lot, maybe a little confusing at times. Identifying domain restrictions is an important part early on in calculus. And let's finish with an AI-generated math joke about domains. So tell me a math joke about domains. I don't know how AI is going to handle this. Let's see what happens. Why did the function go to therapy? Because it had domain issues and couldn't handle its range of emotions. Okay, I can get behind that. That's one of the better AI math jokes I've seen in a little while. All right, so this is skill 6, identifying domain restrictions. Get ready for calculus. Good luck getting ready for calculus. Go to Pythagorean.com if you need more resources. Thanks.